Okay, have you ever walked out into your garden, spotted a dying plant, and immediately started looking for a bug to squash or a fungus to spray? I mean, we all do it, right? But what if I told you that in the vast majority of cases, those bugs and fungi, they're just innocent bystanders, or even worse, they're opportunists just taking advantage of a plant that was already struggling? Welcome to this explainer. Today, we're going to look at plant health not like typical gardeners, but like forensic detectives. So go ahead and put on your imaginary CSI badge, because we are going to crack the case of the dying plant by mastering the art of reading distribution patterns. These are the vital visual clues left behind at the crime scene.
To solve these mysteries, we'll follow a strict diagnostic agenda. First up, landscape patterns. Second, plant patterns. Third, the element of time. Fourth, profiling the suspects. And finally, breaking the triangle.
Okay, let's dive right into this, because there's a fundamental truth here that completely flips the script on how we view plant health, and it's this. Insects and pathogens rarely attack healthy plant tissue. Let that sink in. A lot of times, a plant has already been severely stressed by an environmental or cultural factor long before disease ever moves in. But, because pests and fungi are so visible, they're right there in your face, they're incredibly easy to spot, and so they wrongly take the blame for the whole shebang. To find the true root cause, we absolutely have to stop just looking for bugs and start looking for patterns.
Section 1. Landscape patterns. The broad crime scene.
All right, this brings us to the absolute core focus of our diagnostic toolkit today, distribution patterns. The spatial arrangement of sick plants gives you immediate, undeniable insights into what you're actually dealing with. It basically boils down to a simple binary framework. If you see a uniform distribution of damage, meaning, the symptoms are spread perfectly evenly, or they show up all at once across a whole area, you're almost certainly dealing with an abiotic or non-living problem. Think environmental extremes, chemical drift, maybe severe soil compaction. But on the flip side, if the distribution is random, if it's scattered or clustered in these localized little hotspots, you're very likely looking at a biotic or living pathogen. Things like fungi, bacteria, and insects spread biologically from one initial infection point to adjacent hosts, and that's exactly what creates that random, scattered pattern.
Let's look a bit closer at these specific landscape clues, because honestly, the physical location tells a massive story. If the damage is linear, like it literally follows a straight line, it's highly likely to be a man-made issue. Think a chemical application path or root damage from a trench being dug. What if the problems are isolated to the high areas of the terrain? Well, then you're probably looking at drought or limited water holding capacity. Conversely, if the damage pools in the low areas, you really got to suspect excess water or poor drainage leading to root rot. And here is a huge clue for you. If you notice that multiple, totally unrelated plant families are dying in the exact same spot, like, say, your tomatoes, your lettuce, and the random weeds next to them are all turning yellow, you're dealing with an abiotic environmental issue for sure. Living organisms usually co-evolve to attack one specific plant family. They don't just jump across entirely different species at random. It's just not how they operate.
Section 2. Plant patterns. Zooming in on the victim. Let's move to the individual plant and see how this builds. As we examine the victim, we have to distinguish between two highly specific diagnostic terms, symptoms and signs. This is absolutely crucial. A symptom is the plant's physical response, or its reaction, to a stressor. So things like wilting, yellowing chlorosis, distorted growth, or cankers, those are all symptoms. A sign, however, is the actual, literal physical evidence of the pest or pathogen itself. This could be fungal spores, bacterial ooze, cast insect skins, webbing, you name it. Basically, symptoms tell you the plant is sick, signs point you directly to the actual intruder.
Here's something that beautifully illustrates that exact difference. On one hand, you might spot a fungal sign, like a rust infection displaying highly visible, bright orange, fuzzy spores right on the tissue. That right there, that is the actual organism. Now compare that to a symptom, like a canker. A canker is a localized, cracked, kind of sunken lesion on a branch where the plant tissue has actually died in response to an attack. In that case, you don't see the bacteria or fungi causing it, you only see the resulting structural damage they left behind.
So what does this all mean? The crucial point here is that the exact placement of these symptoms on the plant helps us systematically rule out innocent suspects. If the entire plant is suddenly affected all at once, you can usually rule out a localized leaf disease. It's way more likely an environmental issue or maybe a pathogen that has completely destroyed the root system. If only random upper parts are affected, suspect an airborne living pest or pathogen. And what about the leaves? Well, if you see marginal leaf burn, browning right along the outer edges, that almost always points to a lack of water, excess soluble salts, or a blocked transport system inside the stem. And if the yellowing is super uniform and trapped perfectly between the green veins of the leaf, you are almost certainly looking at a nutritional deficiency. No infectious disease required.
The patterns on the leaves themselves provide some pretty undeniable clues too. A mottled, distinct intermingling of light green and yellow patches on a rose leaf is a classic mosaic pattern, and that is heavily indicative of a viral infection that's systemic, flowing all through the plant. But notice what happens when discolored spots are sharply limited by the leaf veins, creating these very clear geometric angular patterns. When those veins act as a hard physical barrier to a spreading leaf spot, it frequently points us towards specific bacterial infections or downy mildew. It's like a tiny grid mapping out the crime scene.
Section 3. The element of time. Mapping the timeline.
Time is actually one of your absolute greatest allies in diagnosis. You always have to ask yourself, did this happen overnight? If you see a sudden onset of uniform damage, boom, you are looking at an abiotic event. Maybe a late frost, a rogue chemical spray, or a sudden, brutal spike in heat. Furthermore, if you watch that plant over the next few days and the damage doesn't spread to any new growth, well, that abiotic diagnosis is totally confirmed. Non-living problems happen all at once and then they stop, period. However, if the symptoms start small, say just a few spots on the lower, older leaves, and then they gradually expand over weeks, creeping from plant to plant, you, my friend, are tracking a biotic pathogen, a living organism that is reproducing and actively colonizing your garden.
Section 4. Profiling the suspects. Fungi, bacteria, and viruses. Now, what's really interesting here is how phytopathology gives us a very clear way to distinguish between our three main culprits: fungi, bacteria, and viruses. Fungi are by far the most common, and they typically create dry, leathery, or powdery lesions with very clearly defined borders. You'll often even see those visible signs we talked about, like spores or hyphae. Bacteria, on the other hand, they're messy. Their lesions are often water-soaked, slimy, and they can literally smell terrible. They usually lack a defined border unless, of course, they get stopped by a vein. You might even see bacterial ooze. Gross, right? And then there are viruses. Viruses are stealthy. They don't typically cause necrotic tissue death right away. Instead, they hijack the plant's genetics from the inside, causing systemic mottling, distinct color changes, and physical distortion, all with absolutely zero visible signs of the organism to the naked eye.
Let's look at a concrete example of the damage these suspects can leave behind. This right here is a classic case of dieback. Notice the progressive death of the shoots and branches, generally starting right at the tips and slowly moving backward toward the roots. When you see this pattern on a single species out in a landscape, it's a really strong indicator of a biotic issue. We're talking a fungal canker, a wilt pathogen, or maybe specific insect borers literally cutting off the plant's vascular supply.
And sometimes, the suspects don't just kill tissue, they completely alter it. A massive abnormal swelling on a tree trunk like this is called a gall. Galls occur when fungi, bacteria, or insects inject growth-regulating chemicals directly into the plant. They are literally hijacking the plant's cellular production line to create a safe, swollen little habitat for themselves. It is a fascinating, albeit super destructive, visual clue.
Section 5. Breaking the triangle, the final motive.
All right, for an infectious plant disease to truly take hold and cause severe damage, 3 specific things must exist at the exact same time. First, you need a susceptible host plant, one that maybe lacks genetic resistance or is already weakened by stress. Second, you need an active pathogen present in the area. And third, you need a highly favorable environment. Things like high humidity, prolonged leaf wetness, or poor soil drainage. If all 3 of those align perfectly, disease just explodes.
But here is the seriously empowering part for you. You don't have to control all 3 sides of this triangle. If you eliminate just one, the entire disease process is broken. It stops in its tracks. You can choose disease-resistant plant varieties, which completely removes the susceptible host. You can practice proper sanitation by cleaning your tools and removing dead leaves, which removes the pathogen. Or you can adjust the environment, space your plants out for better airflow, test your soil to ensure proper pH and nutrient levels. That prevents the environmental stress that invites the trouble in the first place. Listen, diagnostics doesn't require you to have an encyclopedic knowledge of every single bug and fungus on the planet. Honestly, it doesn't. It just requires you to observe distribution patterns, ask logical questions, and read the clues the plant is practically begging to show you. So the next time you step outside and see a struggling leaf or a wilting stem, I challenge you. Will you look at your garden as just a collection of plants or as an interconnected ecosystem of forensic clues just waiting to be solved? Grab your magnifying glass, look for those patterns, and go crack the case.